Hi y'all, in this video we'll continue to look at determining if arguments are valid. In this example, our argument is if a healthcare reform bill passes, then the bill must have been a good bill. No healthcare bill passed, thus there was no good healthcare reform bill. If I look at this, I can choose P to be a healthcare reform bill passes, and Q to be the bill must have been a good bill. So premise 1 is if P then Q. Premise 2, no healthcare bill passed is not P, negation of P. Premise, the conclusion, thus there was no good healthcare reform bill, should be not Q. Next, we'll determine if this argument is valid. In this example, we want to determine if the statement, if the quantity, if P then Q, and not P, then not Q. Looking at the truth table for this, we see that the final column is not all truths, therefore this statement is not a tautology, and this argument is not valid. In this example, the argument is it's an election year. If I voted, then it's an election year. Therefore, I voted. Let's take it's an election year to be P, and I voted to be Q. That tells us that premise 1 is P. Premise 2 is if Q, then P. And the conclusion I voted should be Q. Next, we'll determine if this argument is valid. Looking at this example, we're trying to determine if the statement P and the quantity if Q, then P, that is, if that entire statement, then Q, is a tautology. Looking at our truth table, we see that the final column is not all true, so the argument is not valid. For the next example, let's look at the argument either I'll go for a run or I'll go biking. I went for a run, so I did not go biking. Here, I'll go for a run, will be P. I'll go biking, will be Q. That makes premise 1 P or Q. I went for a run, P is premise 2. So I did not go biking, not Q, is my conclusion. Next, we'll determine if this argument is valid. In this example, we need to consider if the statement if the quantity, if P or Q and P, then not Q is a tautology. Looking at the truth table, the final column is not all true, so the statement is not a tautology, and the argument overall is not valid. In this example, the argument reads, if Peter climbs up the stairs alone, then his dad will get in trouble. If Peter's dad gets in trouble, then Peter will get in trouble. Therefore, if Peter climbs up the stairs alone, then Peter will get in trouble. Here, we're going to take P to be Peter climbs up the stairs alone. If his dad will get in trouble, will be Q. So the first premise there should be if P then Q. The second premise, Peter's dad gets in trouble, that was Q, then Peter will get in trouble. This argument actually has 3 different simple statements. We'll call this one R then. And that second premise, if Peter's dad gets in trouble, if Q, then Peter will get in trouble, R. The conclusion, therefore, if Peter climbs up the stairs, that was if P, then Peter will get in trouble. Peter will get in trouble was R, so if P, then R. Notice an argument can be made up of any number of simple statements. Next, we'll determine if this argument is valid. To determine if this argument is valid, we need to consider the statement the entire quantity of the quantity if P then Q and the quantity if Q then R. If that entire quantity, then if P then R. building the relatively large truth table for that, we see that the final row, rather the final column, is all true, which made that argument a tautology, which shows us that this argument is valid. This is a good example of a truth table with 3 simple statements, and it shows us that we can really see any sort of argument and use a truth table to determine if it's valid. One last example in this video. This last example shares many similarities with the previous example. Here, the argument reads, if Peter climbs up the stairs alone, then his dad will get in trouble. If Peter's dad gets in trouble, then Peter will get in trouble. Therefore, if Peter gets in trouble, then Peter climbed up the stairs alone. As with the last example, let's take P to be, Peter climbs up the stairs alone, and Q to be, his dad will get in trouble, and R to be, Peter will get in trouble. Our first 2 premises are again, if P then Q, along with if Q then R. The conclusion, however, if Peter gets in trouble, that's R. If R, then Peter climbed up the stairs alone, that was P. So this gives us a slightly different set of premises in the conclusion really being the only part that's different. Let's see what that does to our argument as we go to determine if it's valid. To complete this argument, we're going to look at the statement, if the quantity, if P then Q, and if Q then R, then if R then P. Looking at the truth table for this, we see that the last column is not all true, so the argument is not valid.